Okay, introduce. My name is Rolis Johnson Jawa. My name 192090043. Study program majors Civil Engineering, Manado State University. On this occasion, I will present the assignment of English lecture materials about concise environmental engineering. Okay, just go straight into the material. Okay, the first material is sound pollution. Noise is defined as an unwanted sound in environmental engineering. This is different from the definition of noise in other fields, where noise usually means unwanted information or that is not relevant to the hypothesis or theory being investigated. For example, in telecommunications, noise is the unwanted random addition of a signal. With respect to noise does not have to be random. Easy loud music from neighbors. Noise effects range from moderate to permanent hearing loss and can be assessed differently by different observers. At this time, noise is pervasive and it's almost impossible to avoid it. It is important for environmental engineers to understand noise so that its effects can be reduced on the design and operation of various buildings and machinery. The next material is noise source. Noise can come from point source, easy loudspeakers, channel source, easy power lines under strong winds, or regional source, easy wind noise from the forest. They include source from road traffic, aircraft, industrial planes, construction activities, sports and crowd activities, loud music from neighbors, etc. In time, noise can be classified days. The first, continuous. The sound is not interrupted during the observation period. The second, intermittent. Continuous sound with interruption, such as Danish drill. The third, impulsive. Short duration sounds, usually less than 1 second, like a shot. In contrast to water and air pollution, noise pollution has several unique characteristics. The first, unwanted sounds can be subjective, so they can mean the wrong sound in the wrong place at the wrong time. Therefore, any sound can be noise. The second, noise pollution is usually local. Sound intensity follows the inverse square law with distance from the source. Doubling the distance from the noise source reduces its intensity by a factor of 4. The third, no residual pollution after the noise source is removed. The next material is physical properties of noise. Noise is a wave that is described by wavelength I, frequency f, and speed c connected by. Sound is a compression wave and causes change in pressure in the air. Sound pressure, also called acoustic pressure, is a deviation of local pressure from atmospheric pressure, which is driven by sound pressure sound waves that can be measured using a microphone in the air and a microphone in the water. The next material is human perceptions of noise. The human ear responds differently to different frequencies. Human voice contains frequencies between 80 to 8000 Hz, but mostly in 500 to 1000 Hz. In practice, noise with frequencies above 8000 Hz is usually ignored in monitoring environmental noise because it is rarely encountered it. For noise analysis, the entire range of audible frequencies is divided into a set of frequencies called bands. Each band covers a certain frequency range. In the audible frequency range, the human ear is most sensitive between 2 to 5 kHz, largely due to the resonance of the ear system. The counterweight the same sound is a measure of the level of sound pressure above the frequency spectrum, where the listener feels a constant sound when presented in a pure steady tone. The unit of measurement for loudness is pound and is obtained by referring to the same loudness contour. The next material is noise measurement. Noise is measured by sound level meter. The microphone is one of the main components in the sound level measuring system. During measurements, it must be protected from mechanical dynamics, moisture and turbulence noise from wind. The windshield and special rain cover attached to the microphone shall be used if possible. Sound level meters must be calibrated by a piston pond or sound level calibrator before and after use. When measuring noise levels from a particular point source, distance must always be stated. A distance of 1 meter from the source is usually used. If the distance from the microphone to the sound source is removed when the measurement is quoted, it will make the data useless. In this case of measurement of the environment around background noise, distance does not need to be quoted because there is no single source. The next material is Hall effects. Noise can damage human physiological and physiological health, causing interference and aggression, hypertension, high stress levels, tinnitus, hearing loss, sleep disorders, and other harmful effects. Chronic exposure to noise can cause hearing loss caused by noise in animals. Noise can have an adverse effect on their behavior, increase the risk of death by changing the delicate balance in the detection and avoidance of predators or prey, and interfering with the use of sound in communication, especially in relation to reproduction and navigation. Noise pollution has caused the death of certain species of whales that have been stranded after being hit by a loud military sonar sound. The next material is noise control. There are 3 elements to consider in noise control: source, transmission line, receiver. The first, source. Noise generation can be stopped or limited to certain times of the day. The second, transmission line. This can be modified by placing the source in a soundproof enclosure, building a noise barrier, or using sound-absorbing materials along the path. The third, recipient, where air protectors or chains were sedulous. The next material is climate change, impacts, mitigation, and adaptation. Climate is a long-term statistic. The standard period is 30 years. Meteorological variables, easy temperature, humidity, atmospheric pressure, wind, etc. Statistics include averages, variances, slope, and others. The climate of a location is influenced by land use, land cover, latitude, terrain, altitude, etc. Climate change has major implications for assessing environmental risk and sustainability in the future. It is important for environmental engineers to understand how climate can be changed by human actions intentionally or unintentionally, and what mitigation and adaptation approaches need to be adopted. The next material is climate observation. The details of modern climate are known through measurement of weather instruments such as thermometers, barometers, and anemometers over the past few centuries. Satellites can also be used to pick up surface temperatures in clouds. Free conditions generally through measurements of infrared thermal images. Paleoclimatology is the study of past climates during a large period of Earth's history. This tool uses evidence from ice sheets, tree rings, sediments, corals, and rocks to determine past climate. The reconstruct past climate shows variance in climate in various periods of Earth's history. The next material is mechanisms of climate change. On a planetary scale, global climate is governed by how much energy the Earth receives from the Sun. However, the global climate is also influenced by other energy flows that take place in the climate system itself. This global climate system consists of the atmosphere, oceans, ice sheets, cryosphere, living organisms, biosphere and soil, sediments and rocks, geosphere, all of which affect the movement of heat throughout the Earth's surface. The next material is climate coercion. A climate coercion is defined as an energy imbalance imposed on the climate system both externally and by human activity. National Research Council 2005. The main source of energy that drives the atmosphere ocean system comes from the Sun. The Sun emits most of its radiant energy at wavelengths ranging from 0.2 to 1.8 millimeters, white peak intensities at 0.47 millimeters. On the other hand, the energy spectrum emitted by the Earth is at most around 6 to 25 millimeters. The energy emitted by the Sun is shortwave radiation, and the energy emitted by the Earth and its atmosphere is long-wave radiation. There is very little overlap between them in the spectrum. Solar energy is significantly weakened when it reaches the surface of the Earth at sea level. This is not uniformly attenuated across the spectrum, but instead large energy losses occur in a rather narrow band, called the absorption band. In a clean, cloud-free atmosphere, the main dampers of shortwave radiation are water vapor and ozone. Airborne particles or aerosols in typical non-polluting air contribute less to absorption. Absorption of long-wave radiation occurs in a series of bands. The main natural absorbers of long-wave radiation are water vapor and carbon dioxide, and some small players such as ozone, methane, CFCs, and nitrous oxide are much less influential. They are the main greenhouse gas. The basic concept of a greenhouse was proposed by Fourier 1827, then Arrhenius 1896 calculated the effects of various concentrations of carbon dioxide on surface temperatures and even include the effects of water vapor uptake in his calculations. Cotton and Pilke 2007 pp 155. The most important greenhouse gas is water vapor, which varies naturally in space and time due to the Earth's hydrological cycle. The second most important greenhouse gas is carbon dioxide. Unlike water vapor, carbon dioxide is somewhat evenly distributed throughout the troposphere. The radiation properties of aerosol particles are a complex function of the chemistry, shape, and size of the spectrum. In addition, if the aerosol particles are hygroscopic, the radiative properties change with the relative humidity of the air. Dry aerosol particles in high concentration, such as in major polluted urban areas and excessive desert, can cause substantial absorption and scattering of solar radiation. The next material is climate feedback. Climate feedback is the strengthening or dampening of the climate response to special stresses due to change in the atmosphere, oceans, land, or continental glaciers. Water vapor is the main greenhouse gas, and any change in water vapor concentration in response to greenhouse gases will substantially change the clean greenhouse heating. As the atmosphere and oceans warm up in response to increased greenhouse warming, more water vapor evaporates from the surface of the sea and land. The higher moisture or content of the atmosphere causes further warming of the greenhouse, which then causes more evaporation. Positive feedback. Change in the coverage of snow and ice on the surface respond positively to greenhouse warming. Snow and ice reflect more solar radiation than open water, bare land, or land covered by plants. As a result, warming of the high latitude troposphere is expected to reduce the sea ice cover accordingly, and cause previous seasonal snow melt and retreat on glaciers. It is estimated that these effects will positively strengthen greenhouse warming by 10% to 20% globally. Hansen, 1986, feedback of ice albedo and snow albedo is difficult to accurately model, and existing climate models fail to predict and match change in sea ice cover observed in polar regions. The next material is modeling climate change. Despite the difficulties and uncertainties with climate modeling, many research organizations have developed climate models to help assess various coercive components and feedback. There is still a long way to go before these models can provide accurate estimates. Climate models use quantitative methods to simulate interactions of the atmosphere, oceans, land surface, and ice. They are used for various purposes, from studies of climate system dynamics to future climate projections. The use of the most tell about climate model in recent years in projecting change in temperature resulting from increased concentrations of greenhouse gases in the atmosphere. All climate models take into account energy that enters from the sun as solar wave, electromagnetic radiations, especially infrared and solar waves near and outgoing energy as long waves, far infrared electromagnetic radiation from Earth. Any imbalance results in temperatures change. GCM Global Climate Model or General Circulation Model describes equations for fluid movement and energy transfer and integrates them from time to time. The next material is importance of natural variability. No climate model can adequately predict or even explain this rapid transition. Short-term variations in weather and climate are clearly within the natural variability of climate to the extent that we can realistically assess. In addition, these models are not really approximate models. Built 2002, they are just research models designed to simulate response to anthropogenic change, hypothesized to weather and climate, other things being equal. This simulation model should be more accurately called a process study, not a prediction, with their many limitations in their descriptions of climate pressure and feedback. They are unable to predict climate change with high confidence. We don't know enough about all the processes that are important for climate change to include them in quantitative forecasting systems. National Research Council 2005. The next material is impacts of climate change is reflected in change in various aspects of concern to creatures and ecosystems. In the physical world, climate change triggers global and regional weather change. In general, future climate change projections on a regional scale do not have as high a level of scientific confidence as projections made on a global scale. Temperature changes are more visible on land and polar regions than in the oceans, and more in high latitudes than in low latitudes. Rainfall throughout the world is expected to increase, but with a substantial shift in where and how rainfall falls, intensity, frequency, and type, with decreases in rainfall in some areas. Also, the extreme increase of summer and winter droughts in winter is projected for most of the world, which means the risk of drought and flood is generally greater. There is widespread melting of snow and ice with visible glaciers, reductions in the area and thickness of glaciers, and ice sheets, and rising global mean sea levels. For volcanoes and earthquakes, retreats of glaciers and ice sheets can cause increased volcanism and seismicity due to reduced restraining pressures that occur on the Earth's crust. The effects of climate change on human health are reflected by exposure through change in weather patterns, temperature, rainfall, sea level rise, and more often extreme events, and indirectly through change in water, air, and food quality, and change in ecosystems, agriculture, industry, settlement, and economy. On the other hand, climate change will bring several benefits in temperate regions, such as fewer deaths due to cold exposure and some mixed effects such as climate change, climate engineering impacts, mitigation and adaptation change in the range of potential of malaria transmission in Africa. In extreme events, climate change is expected to increase the number of people who suffer death, disease, and injury due to heat waves, floods, storms, fires, and drought. For water resources, the impacts of climate change on freshwater systems and their management is mainly due to change in temperature, sea level, and rainfall variability. In the biological world, the impacts of climate change include the previous clearing of trees and plants in many regions, the movement of species to higher latitudes and elevations to find cooler temperatures, change in migratory birds, and shifts of ocean plankton and fish from the cool to warm communities that adapt. The amount of oxygen dissolved in the ocean can decrease with bad consequences for marine life. Ocean acidification in the marine biosphere may have several beneficial effects for some species, with potentially devastating effects on a large number of species. Pressure caused by climate change coupled with other pressures on the ecological system, land conversion, land degradation, harvesting, and pollution, can cause great damage to some unique ecosystems and the extinction of some endangered species. Climate change is thought to be a major driver of loss of biodiversity in cool coniferous forests Sifinus, the Mediterranean climate system, tropical forests, Arctic tundra, and coral reefs. Okay. Physical, ecological, and social systems can respond by means of sudden, non-linear, or regular climate change, as opposed to smooth or regular response. A regular behavior in the Earth system can cause certain thresholds, critical points, which if crossed can cause major change in the system. Climate change caused by humans can cause irreversible effects on physical, biological, and social systems. Species extinctions, loss of unique human culture due to displacement of communities by rising sea levels. It is possible that human-induced climate change can trigger large-scale singularities, but the possibility of triggering such an event is still poorly understood. Next material is mitigation. Climate change mitigation is human intervention to reduce the potential impacts of climate change by reducing sources or increasing the amount of greenhouse gases. It should be noted that stabilizing GHG emissions is not enough to stabilize GHG concentrations. Examples of mitigation include using fossil fuels more efficiently for industrial processes or electricity generation, switching to renewable energy, solar power, tidal and oceanic energy, geothermal power, and wind power, and many more controversial nuclear power, increasing building insulation, expanding forests, and other things to remove large amounts of carbon dioxide from the atmosphere, changing individual lifestyles and business practices. Next material is adaptation. Adaptation to climate change is taking action to overcome the effects of climate change. Adaptation is needed because climate change and its impacts cannot be mitigated in a short time. Adaptation will be more difficult for larger magnitudes and higher rates of climate change. Climate change adaptation is very important in developing countries because these countries are predicted to bear the burden of climate change impacts. Adaptive capacity is closely related to social and economic development, and developing countries generally lack the ability to adapt. Adaptation can be defined as system adjustments to reduce vulnerability and to increase the system's resilience to change. Adaptations occurs at various interrelated scales and can occur in anticipation of change. Anticipatory adaptation, most of the adaptations applied today are responding to current climate trends and variability. For example, increased use of artificial snow in the European Alps and some adaptation measures. However, anticipating future climate change, for example, to design a bridge that is quite high with expected water level rise. Planning is an important avenue for adaptation by allocating land use for ecosystem protection. In cities, it may be appropriate to change the varieties of heat-tolerant and water-permeable trees to absorb higher rainfall. Sustainable drainage systems can help urban areas adapt to increasingly severe storms by increasing rainwater storage and increasing the capacity of rainwater systems. Gardens can use plants that require less water and provide habitat for the most truant species. For agriculture, it is important to develop crop varieties with weather drought tolerance and increased investment in irrigation. Easy modern efficient irrigation systems, small-scale water storage ponds. Weather control techniques can be explored. Easy cloud seeding to trees to produce rain when and where it is needed. Glacier lakes that are in danger of bursting can have their moraines replaced by concrete dams, which can also provide hydropower. Migration can also be considered when other mitigation measures prove unsuccessful.